Now, whenever I do a stoichiometry problem, the most important thing that I do is I write out a little plan of attack. Okay, here's the plan of attack. If I have grams of substance, we'll call it substance A, and I want to change that into moles of substance A, I always use the molar mass of A. Okay, we get that from the periodic table. We add up the different elements and we get the molar mass. Now, in order to convert from moles of one thing to moles of something else, I'm going to need a balanced equation. So hopefully you remember about balancing equations. And then also, if I want to go from moles back to grams, I again need a molar mass of substance B this time. Now, each of these arrows here represents a domino. Okay, so let's do an example of this. Let's say that I'm given this equation right here. Okay, let's say that I'm given NH3 plus I2 going to Ni3 plus H2. Okay, this is a fun little reaction. This is actually kind of a simplification of it, but Ni3 is actually it's a contact explosive, nitrogen triiodide. You should try looking it up on YouTube. Lots of fun. But anyway, here's what we're going to do. Let's say that the problem tells us that you have 6.5 moles of iodine, and I want to know, well, how many moles of nitrogen triiodide can I make with that? Well, looking at this, the first thing I check is, well, I have moles of one thing, so I'm starting right here at moles, and I'm turning that into moles of something else. So it looks like I'm only going to have one domino, and that domino is going to be my balanced equation domino. So I need to balance this. Let's see, I have one nitrogen. I have 3 hydrogen, 2 hydrogen over here. So remember that anytime you run into this even-odd problem, we're going to double everything we already balanced. So we already balanced our nitrogen. We said that there was 1 nitrogen here. Well, let's double that and put a 2 here. There's also nitrogen over here. So now we have 2 nitrogen on the left, 2 nitrogens on the right. But now we have 6 hydrogen. So if we put a 3 here, now we have 6 hydrogen. We also have 6 iodine. Putting a 3 out front now gives us 6 iodine over here. So now we have a nice balanced equation. That's what we need. So let's go ahead and set up our typical domino problem. Okay, now we have, let's see, what number are we given in this problem? Well, we're given this one right here, 6.5 moles of I2. Let's go ahead and write that in the top left-hand corner. Okay, on the bottom right, we're going to put question mark moles of Ni3. Now in this case, we know that this problem only involves one domino. It involves a balanced equation domino. So I'm just going to put one domino in the center. Now a balanced equation domino always looks the same. It always says moles of what I started with on the bottom. So in this case, moles of I2, because that's what I started with. Okay, moles of what I want always goes on the top. I want Ni3, right? I'm trying to get question mark moles of Ni3, so that moles of Ni3 has to go on top. Now these numbers here come from the balanced equation. We're looking at the coefficients. So I look at I2. Well, I2 has a 3 in front. Because there's a 3 in front in the equation, I have to have a 3 in front of the moles of I2 on my domino. Now, for moles of Ni3, you'll notice that my balanced equation says 2, which means I need a 2 here. Now, you'll notice that moles of I2 cancel, top and bottom. Moles of Ni3 cancel, top and bottom. I know that I'm done here, okay? I don't need to include any other dominoes. Now it's just multiplication. So 6.5 times 2 is going to give us 13. On the bottom we have a 3. Okay, 13 divided by 3 gives us 4.3. You'll notice that we had 2 sig figs to start with in our problem, so we better end up with 2 sig figs in our answer. Well, what are our units? Well, question mark moles of Ni3, so that has to be our unit. going to be 4.3 moles of Ni3. So that's a typical stoichiometry problem. You'll notice that only involved 2 dominoes though, so that's kind of a simple one. Let's go ahead and try one that's a little more complicated. Now again, I'm going to quickly write up my little plan of attack up here. Okay, grams of A turning into moles of A. I use my molar mass. To go from moles of A to moles of B, I need a balanced equation. And then to go from moles of B back into grams, again I need the molar mass, but this time it's the molar mass of substance B. Let's try one more. Let's say that we have hydrogen burning in the presence of oxygen and turning into water. Okay, let's say that this time I have 46 grams of oxygen, and I want to know how many grams of hydrogen are needed to fully react with my 46 grams of oxygen. Okay, well let's go ahead and set up our domino problem. Okay, looking at this, I notice that I'm going from grams of one thing to grams of something else. So I'm going from grams of substance A all the way over here to grams of substance B. That means that I need 1, 2, 3 dominoes, okay? So I need 3 dominoes here in the center. Okay, 3 dominoes here. Now, the number that I'm given in this problem is 46 grams of O2. So we're going to go ahead and put 46 grams of O2 in the top left-hand corner, okay? On the bottom right, we're going to put question mark grams of H2. Now, I need 3 dominoes. The first one I'm going to need is the molar mass of substance A. A is the substance that I started with, which is O2. Now, if I look on my periodic table, oxygen has a molar mass of 16, but it's O2. So that means that 1 mole of O2 has a mass of 32.00 grams. Okay, you'll notice that the grams of oxygen cancel. Okay, now I have moles. So that was my molar mass domino. Now I'm in moles. Now I need to use this balanced equation domino. So I better have a balanced equation. So let's quickly balance this. Now we have a balanced equation. So my balanced equation domino should always look the same. Moles of what I started with, which is O2, goes on the bottom. Moles of what I want, which is H2, has to go on the top. Now, what are my coefficients in my balanced equation? Well, in front of the H2, I have a 2. So I better put a 2 there. In front of my O2, there's no number. So remember, if there's no number written, it's a 1. So let's go ahead and put a 1 there. Okay, and then that's my balanced equation domino. You'll notice that moles of O2 cancel. Now, the last domino I'm going to need is the molar mass of substance B, which is H2, right? So 1 mole of H2, well, if I look at my periodic table, okay, I pull it out of my wallet, never leave home without it, it says that hydrogen has a mass of 1.01 grams, but again, it's H2, so I have to add that up. So 2 hydrogens would be 2.02 grams. Okay, now you'll notice that moles of H2 cancels, grams of hydrogen cancels, everything cancels, so I know that my problem is done. Now it's just a matter of plug and chug. So I go ahead and multiply my top numbers. 46 times 1 times 2 times 2.02. That ends up giving me a 185.84. Okay, on the bottom, we have 32 times 1 times 1, which is a 32. Let's go ahead and plug that in. And it comes out to 5.8075. Okay, now, well, how many sig figs can we have? Well, we started with 2, so let's go ahead and keep 2 in our final answer. So we're going to write 5.8, and what are the units? Well, it says question mark grams of H2, so this has to be grams of H2, and that